Today we're learning section 1.5, equations and mental math. We should be on page 26, I believe. Page 26 in your books. Alright, so in example 1, we are checking for possible solutions here. We're checking for possible solutions. So we have here an equation, and the equation is n plus 5 equals 12. So I'm going to use that equation as my original problem. So go ahead and write that in your notes under example 1. So first step is to write the original problem, and then we're going to substitute what the possible solution is in for n. Okay, so 9 is going to substitute in for n. And now what's 9 plus 5? Xavier? It's 9 plus 5. It's 14. Very good. 14, wait, does 14 equal 12? Does 14 equal 12? No. Okay, so no, this is not a solution. N equals 9 is not a solution for this equation. Now let's look at the second one. N equals 7. Again, we start with the equation n plus 5 equals 12. We make our substitution. 7 plus 5 equals 12. Is that true? 12 equals 12? Yes, it is. So I would say yes, it is a solution. This is exactly how you're going to write it on your homework tonight. All right, so now I want you to practice a few. All right, I want you to do your turn now. Numbers 1 through 3 on the top of page 27. You're doing them exactly like I just did the first two examples. So you're checking to see if each one of these values is in fact a solution. I want to see original problem, substitution, and a boxed answer. There should be 3 steps. All right, so let's go over the answers now. Okay, so on number 1, you should have shown a substitution. 3 times 4 equals 12. Now simplify both sides. So 3 times 4 is 12. 12 equals 12. Yes, that's what should be boxed as your answer. Number 2, notice that the equation is written kind of backwards. That's okay. Your substitution should follow the same pattern. 7 equals 13 minus 5. 13 minus 5 is 8. So you should have 7 does not equal 8. No, boxed in. That is not a solution. And then on number 3, make your substitution, and 3 equals 3. Yes. All right, raise your hand if you got them all right. Did you get them all right? Okay, very good. All right, now in example 2, this is something you're not going to hear very often from me. You're not showing work. On example 2, you're doing the math in your head. You're doing it mentally. Basically, you call it mental math. But anytime you see a variable, like in the first one we see an x, second one we see an n, t, and an m, we're going to replace that with the question, what number? We're going to replace it with the question, what number? All right, so on number 1, 9 plus what number equals 12? And what would the answer be, Joshua?
3.
Very good. So the way that I would write my answer is x equals 3. Don't just write 3. You need to make sure that you write the variable as well. So x equals 3. Number 2, n minus 5 equals 10. So now I ask myself, what number minus 5 equals 10? What would the answer be? Brandon? 15. Very good. So I would say n equals 15. 4 times what number equals 20? 4 times what number equals 20? Brandon? 5. Very good. 4 times 5 equals 20, so t equals 5. And then on the last one, m divided by 3 equals 12. And what number divided by 3 equals 12? Brandon? No. Joshua?
48.
No.
Oh, wait, no, not 48.
Destiny? 36. Very good. 36. So m equals 36. All right, and a little trick here, okay, that you can apply. Most of the time this works. So if you're kind of at a loss as to where to start and you're having trouble figuring out what the number is, you can look at the original equation and look at the operation. Okay, so in number 1, what operation do I have? Addition, subtraction, multiplication, or division? Which one? I drew an arrow to it. I'm adding, right? So the way that you can solve this in your head mentally, you don't even have to write anything down, you're not supposed to, is you do the opposite of the operation and you do it with the two numbers that you know. So since I'm adding here, I'm going to subtract 12 minus 9. What's 12 minus 9?
3.
Well, ironically, that's the answer, isn't it? All right, now on number 2, I'm subtracting. I'm subtracting on number 2, so what's the opposite of subtraction?
Add.
Addition, so let me add the two numbers that I know. What's 5 plus 10?
15.
Ironically, that's the answer, isn't it? Okay, do you see what I'm doing here? On number 3, what operation is in that equation? What is it? I'm multiplying, so what's the opposite of multiplying? Dividing, so what's 20 divided by 4?
5.
It's 5, very good. And then on the last one, I'm doing what? I'm dividing. What's the opposite of division? Multiplication. So what's 3 times 12? 36, and that's the answer. Now, the only time this doesn't work, and this might be the part of the video that you need to go back and watch on YouTube, the only time this doesn't work is when I'm subtracting or dividing, and my variable comes as the second term. So on number 2, if it said 5 minus n equals 10, okay? I couldn't simply add 5 and 10 together to get 15. It wouldn't work out. If the variable comes second, that trick doesn't work. Same thing with division. If this was, say, and I'll make up a different one, 12 divided by x equals 4, you couldn't do 12 times 4 equals 48. You wouldn't get the right answer. So if that variable comes second, the trick doesn't work. But other than that, that little trick that I just showed you, that works for solving these mental math problems, okay? And that makes it just a little bit easier. All right, so that's it for example 2. I want you to go ahead and do your turn now, numbers 4 through 7. Your turn now, numbers 4 through 7. Okay, so again, you're asking yourself, you're inserting wherever you see the variable, you're inserting the question, what number? 7 times what number equals 35? What is it? 5. So x equals 5. Make sure you say the x equals, or write that on your paper. All right, number 5, 15 equals n minus 6. So you can use the trick here. There's subtraction, so what's the opposite of subtraction? Addition, so what's 15 plus 6? 21. Now go back and check. Is it true that 21 minus 6 is 15? Yes, it is, so I know that's my solution. On number 6, 12 plus what number equals 32? All right, well, I'm adding, so I can do the opposite. So 32 minus 12 is 20, so A equals 20. Do you see what I'm doing there? Now, number 7, the trick doesn't work, and why not? Why doesn't the trick work on number 7? Xavier? Well, sometimes it does work on division, but it only works if the variable comes first. Since the variable comes second here, it's not going to work. You can't do 24 times 6 and get the answer. You just have to ask yourself, 24 divided by what equals 6? And the answer is 4. And you get the solution. All right, one more example, and it involves the distance formula. All right, so the first thing you need to know is, what is the distance formula? All right, and that's distance equals rate times time. So you need to write down the formula and what each variable stands for. D stands for what? D stands for, it's right there. D stands for distance. R stands for the rate or the speed. And T stands for time. All right, so you should be writing this down. Okay, now let's turn to page 28 and read the example together. All right, example 3. It says a homing pigeon is a bird trained to fly back to its home. Homing pigeons can fly at a speed of about 50 miles per hour. About how long would it take for a homing pigeon to fly 300 miles? All right, so the first thing I need to do, anytime I am working a problem that involves a formula, the very first thing that I'm going to write is the formula, which you should have just written down, D equals RT. Now I need to go back to the problem, and I need to ask myself, what values do I substitute in for which variables? So D stood for what now? D stood for the distance. Does it give me a distance in this problem? What is my distance? What's my distance?
300 miles.
300 miles. So I plug in 300 where D goes in the formula. You see that? Did it give me a rate? Did it give me a speed?
50 miles per hour.
50 miles per hour. So I plug in 50 where R goes in the formula. And then it asks me how long would it take. So do I know T?
Yes.
No, I don't. It says how long would it take. You have to figure it out. Now this is very important. If you do not have an equation on these problems, you're not going to get credit for the answer. You have to have an equation. You can't just say, oh, well, I just knew what the answer was. I just looked at it. And the reason is because these concepts will get much more complicated, and it's important that you learn how to plug in the numbers into the formula and then solve. Now, from this point, you're going to ask yourself now, you're going to use mental math to solve, 50 times what number equals 300? Now, you might not know that right off the bat, okay, or if the answer's not right in front of you in the book. So, what operation is in this equation? What operation is it? It's multiplication, right? 50 times T. So what's the opposite of multiplication?
Division.
Division. So divide the two numbers that you know. What's 300 divided by 50?
6.
6. So T equals 6 hours. You see how we did that? All right, so if you're having a hard time figuring out what number multiplied by 50 would give you 300, you can solve it that way by doing the opposite. Okay, doing the opposite with the two numbers that you know. Okay, and if you understand that, that's everything you need to know for 1.5.